Morning. Good morning, class.
Good morning.
We love you, Miss Hannigan. Anybody get that reference? Little Orphan Annie? No? I guess you'd have to be born about 50 years earlier. Alright. So, some important information has been published. So, ahem.
Sorry, Mr. Ward.
Dr. Mr. Morty, you.
Dr. Mr. Ward.
Thank you. So, the midterm then. The midterm will be held in week 8. It will be held on the following dates and times depending on what section you/we are in. In this case, we are section 9. So, we will be holding our midterm
Monday.
October 28th on a Monday, yes, at 10 a.m. This is what I have decreed, and I am the sovereign benevolent dictator for life of this course, so that is when we shall hold it. So, just to recap the calendar, still a lot of chatter going on. Hit him! We are currently in week 5. Assignment 1 is due this week. Next week is week 6. That is when assignment 2 will be distributed to everybody. I hope everybody likes assignment 2. I'm really liking how it shapes up. After that, the week of the 13th, this is reading week / Thanksgiving, which is on the Monday. So no classes are to be held here. In the schedule for this course, reading week does not count as a week. So when I say that the midterm will be in week 8, I am excluding reading week from that consideration. So, the week of the 20th is when assignment 2 will be due. After that, the week of the 27th, that is when we shall be having the midterm. And after the midterm week, the assignment schedule will be back into the, bi-weekly assignments, sort of, until we hit December. That's actually kind of a lie. The last assignment you have like 3 weeks for, just because of the way it works out. We could have gotten 5 assignments in. But somehow I don't think people are displeased that we only have 4. So, any questions about the schedule? Everything makes sense? Everything clear? Okay. Anybody going to argue with me about what section this actually is? In the last class, somebody was like, but we're section 9 though. I'm like, but it says section 11 here. It's okay. It was fun times. So, assignment 1 then. How is assignment 1 coming along?
I haven't started.
You should probably start it.
Yeah, I know. I'm catching up. I was sick last week.
Well, I forgive you. Just get it in on time. You have a question.
I opened it and I closed it immediately. It was too overwhelming.
You need to work on your fortitude and your courage.
Yes, sir, Doctor.
If a piece of paper intimidates you, you need to work on your courage. So, there was one thing that I wanted to bring forward for the class. This was a question that was asked. Thank you. This was a question that was asked in the other class. I think the answer to it is of benefit to everybody. So I'd like to answer it again, even though nobody's asked it. So, with respect to the ants, the marching ants problem, right? It seems people are having a little bit of difficulty with the concept of the mutually assured destruction outcome, or the MAD, M.A.B. outcome. So, the idea here is that a black ant reaches the red nest and a red ant reaches the black nest, irrespective of when that would occur if you were to simulate it. So the simplest string which results in a MAD outcome is this one, R and B, right? Red is traveling this way, black is traveling that way. They do not intersect. Therefore, red reaches black, no, that is actually red, and kills it. Same thing on the other side, mutually assured destruction. However, one of the questions was, in the other class, what if you have a scenario like this? What if it would take red some time to reach black's nest? Black wins first. Doesn't that mean that it wins ultimately? And in this scenario, no. So, I'll give you a couple of hints. Number one, the x's are actually irrelevant to the outcome of the algorithm. They're a type of red herring, actually. You can, if you want to, pre-process all of the x's out of the incoming string, then proceed with it as normally, and your outcomes would still match up with the chart. Right? So, what I'm looking for is the eventual end result. Right? In my scenario, it doesn't really matter all that much. If Russia and America fire their nukes at each other at the same time, it doesn't really matter to me which one gets there 5 minutes earlier, they both lose. Right?
Either way, not my problem anymore.
Beautiful analogy.
Right? I mean, there you have it. Of course, we're also saying that one ant is enough to beat an entire ant's nest. Presumably the anthills have more ants in them. But we are simplifying things for the sake of logic. So, does that make sense? So, you could be led to think this way if your approach to solving the problem was to simulate out. Sorry, did you have a question?
Yeah, just regarding this, is it all right if you also accept the lowercase character versions of that as well, or do you just want the uppercase?
I'll only be testing you for the uppercase. If you include the lowercase, it's not a problem. Yeah. Yeah. So long as the work is your own, I'm not really particular about the solution. So there are two main approaches to solving this problem, right? The first is to run the simulation, right? Which requires doing a series of swap operations in the array and replacing r's and b's, like replacing an r and a b with an x if an r was to swap into a b's location, or vice versa, right? To run that scenario out requires a nested loop, a 2D, right? You need one loop to be running through the string performing the swaps. You need a little bit of look back. The other loop needs to run that loop until there are no ants remaining on the table, or they've all been shifted to the ends and you count them, or however you want to do it, right? So in terms of computational complexity, the simulation algorithm would be big O n squared. However, and this is the galaxy brain approach, it is possible to come to the correct solution for one of these using a single pass algorithm, right? If you use a single pass counting algorithm, it is possible to come to the correct solution from the string, and you don't need the nested loop. You can just walk through it once, making that solution big O n, because it's linear. I don't care which of these two you use, so long as it works, right? If it works, I'm happy. But because of the added complexity of this solution, this one's actually more vulnerable to bugs. You probably spend more time debugging this one than you would debugging this one, just because it's a lot less complicated, right? You can kind of think of the amount of debugging work you have to do as being proportional to the lines of code that you write, right? The longer your algorithm is, the more time you are, the more mistakes it likely contains. And this is why, when you see like, LeetCode and people like that, there's a tendency towards minimizing the amount of code that you write. And it's because if you try to minimize the amount of code you write, you're also minimizing the possible injection sites for bugs into your program. Does that make sense? Yeah. So these are not skills I expect you to master just yet. You need to, you folks are no longer newbies, right? You are no longer, I just started programming. You have been doing this for a year now, so you should start to come to appreciate some more advanced techniques and topics. Yes, sir.
Just wanted to know if this would be the right way of thinking about it. If we use the do-while loop for this, isn't it possible to actually complete it that way, because the do-while already goes over it once before executing and then goes over it again? So it's technically running twice instead of the nested for loop?
Well, a do-while loop will literally do anything a while loop does, depending on how you configure things, right?
I just mean for time complexity. Like, would that be technically?
Oh, no effect.
No effect?
No effect.
It's still big O then?
Yeah, or n squared, yeah.
N squared, yeah. Okay.
Yeah, so the way that big O works is it doesn't count like single individual cases when you're coming up with complexity. Like, for example, you've got some scenarios like, take for example, a stupid implementation of bubble sort and a complex implementation of bubble sort, right? A stupid implementation of bubble sort doesn't understand that the array is becoming more sorted as you go along, right? So, you guys know bubble sort?
Yeah.
A little bit? You guys have done bubble sort before?
Yeah.
Yeah. So, like, the idea with bubble sort is after each pass through the algorithm, one number, like either the maximum or the minimum number, depending on how you've configured it, finds itself in the correct position at either extremity of the array, right? If you just iterate bubble sort without realizing that, you retest those things that are in the correct position, right? So you have n squared, you actually have n squared cases where n is the number in the array, or the number of elements in the array,
Yes.
right? If you have a slightly smarter bubble sort algorithm, you can actually do one of these, n squared by 2, right?
Okay.
Because on your first iteration, you use the whole thing. On the second, you've got 1 decided, then you've got 2 decided, then you've got 3 decided, etc., all the way down to where, like, your second to last one, you're only deciding between 2 values type thing, right?
Oh,
right?
Yeah.
So in total, the total number of cases you're processing is n squared by 2. So half the number of cases, just by recognizing where the thing is stored, where it is. These are both still big O n squared, because this n squared by 2 is actually half times n squared. Big O notation drops all constants.
Okay.
So it drops the constant, that's all that's left, it's big O n squared.
Okay.
But you'll have plenty of time to talk about that in algorithms. So, camera's on, right?
Yeah, the red light's on.
There we go, alright. So, yeah, so, like, I'm not saying that efficiencies like that aren't important, but, like, what big O is an attempt to measure, what it is actually a poor attempt to measure, is the rate of expansion of the processing as you increase the size of the input. So, fundamentally, it's still proportional to the square. So, no questions about assignment 1 otherwise? Yes?
In question 2, the factor question, it asks for an ordered list. Just to clarify, does it mean a list ordered, or does it mean like an HTML ordered list?
Oh, I meant HTML ordered list.
Okay, good to know, thank you.
Yeah. I mean, I'm trying to think of an algorithm that would produce the numbers out of order.
Oh, I just sorted. Yeah.
But like, if you're testing for factors and you're going through sequentially,
Yeah.
they're going to either be in ascending order or descending order, because that's ultimately a filtering operation on the natural numbers, right?
Yeah.
So like,
I just wanted to make sure I wasn't like confused.
yeah, no, when I said I want an ordered list, I want the ordered list a la HTML.
Yeah, thank you.
So, yeah.
Good.
Any other questions? Okay. So I think we have a couple of small topics to clean up on XSS attacks. Couple of small topics on XSS attacks to clean up, and then we'll be on to our new material for the week. So, let's remind ourselves of the scenario that we ran through in class last week. If you recall, we had our website owner Bob, who wrote a terrible website. We had what was the little old lady's name in this class?
Gertrude.
Gertrude, yes. We had Gertrude, the little old lady, who got horribly, horribly victimized by internet scammers. And then we had,
Hunter.
yeah, Hunter the evil hacker.
Yeah, Hunter because he was hacked.
Yes. And, you know, so in that scenario, Gertrude has an account on Bob's website. That account contains sensitive information like credit card details. Hunter the evil hacker sends email containing phishing link to Gertrude. Gertrude clicks on it. Our hacker steals the session cookie, has a duplicate session running, locks Gertrude out of her account, views her credit card details, uses them to make illegal purchases, i.e. crime. right? And all of this just because Bob couldn't have his nephew write a website that didn't have a very simple reflected XSS attack. That simple thing was a vulnerability. So let's consider a few different ways this scenario could be expanded or contracted, because there's more than one way to hack a website. So, number one, in the scenario that we were talking about, our hacker stole a session cookie. This is good, but it's not the only damaging thing that a criminal could do, right? Consider this little piece of JavaScript right here. There we go. So, stealing a session cookie is kind of like a bold move, because there are a lot of things that could fail there, right? If the website's doing tracking to make sure that session cookies are valid and coming from the same place, not coming from two different places simultaneously, that type of thing, then just stealing the session cookie is not going to do anything. Consider this. Credit card number field, add event listener key press, gives you event fetch evilsite.php keystroke is equal to key event. You know what this is?
Is it a logger?
Yeah, that's a key logger that's been attached just precisely and exactly to the credit card number field of some online web form. It's not as direct an interference as trying to lock someone out of their own account, which these days is pretty difficult anyways because most sites require you to re-enter a password in order to do so, which, the hacker won't have if all they've done is steal the session cookie, right? If you've stolen the session cookie, you don't actually have the original credentials, right? But here, as the number is being typed in, that number is being sent off to some evil website where it's being collected for later use. And this can just sit like a rotten spot on a tomato, on the backside of a tomato where you don't see it. This is the worm in the apple. You can have this sitting on a website and it's reasonably unobtrusive, but it still has the same effect, which is to steal the credit card. Make sense? So, never trust the user. Never trust the user. I'm going to skip the thing where I list a whole bunch of famous hacks. We don't really, people who are in and around the Hamilton area really don't have to go very far to think of a famous example of a hack. Yes?
Wasn't the library, the government libraries, in Hamilton specifically attacked, and it was down for a long time?
No, it was a lot worse than that. Yeah, the whole city of Hamilton lost every database.
That's why on the buses we didn't even have
Yeah,
the stopping sound or anything.
Yeah,
it got so bad they couldn't move.
the system the call system that tells you when the bus is going to be there is down. The thing that tells the buses if they're ahead or behind schedule is currently down. Library computers are currently down. The city lost a whole bunch of health records. That's gone too. The entire municipal, they lost. Basically, if you got a parking ticket and you didn't pay it, before the system went down, you're laughing. You don't have to. Maybe they went back after them. I'm not sure. Did they ever get the old parking tickets back? I forget. I didn't hear.
I'm a good citizen, I wouldn't know.
Yeah. So yeah, like the parking ticket system was down. Property taxes were down for a while. They got that one back up and running because that's like a main revenue source for the city. I think for a little while, like you could like park in municipal lots for free for like a week or two afterwards. Yes.
I noticed that once it went down, like hackers noticed and they started sending like these fake parking things, like parking texts to people to
Yeah.
trick them to think, oh, we got it back up and running, so you owe this or this.
Yep. Oh yeah.
Because I got it, but I never parked it. Like,
The weakest part of every system is the human element, right? Yeah, it's horrible. But yeah, so the city is still out and down. I guess they wanted a lot of money in ransom because from what I hear, the city's solution to this problem is they're just gonna redo everything from scratch.
that's crazy.
Yeah.
Health records too.
Yeah, they lost health. Oh yeah, lots of health records. Oh no, yeah, specifically vaccination records. So I hope you all kept paper copies of your COVID shots, eh?
I mean, I got screenshots.
Yeah, yeah, there you go. So there was another one that I was going to talk about. City of Hamilton, libraries.
My question is why Hamilton, not Toronto? Like, Toronto's like.
Well, you have to.
Pick on the little guy.
I mean, that's actually a really good question. I mean, like, the somewhat facetious answer is because they could, right?
Maybe Toronto has a budget for security.
Or, maybe they're more on top of this sort of thing, probably because it's a much larger city. Why Hamilton? Like, because, they probably tried a few, and we were the ones where they got through, So, you had a question or comment?
Was it the Life Labs or something, the private clinics?
Yes, Life Labs had a leak too. They lost all kinds of client data. So, like, attacks can be destructive or non-destructive, right? The thing that happened at the city of Hamilton was a ransomware attack, which means that basically somebody went in and encrypted all of the databases and all of the hard drives and said, for the encryption key, we would like $1 million. So, obviously they wanted more than $1 million, or the city would have probably just paid it. Probably what happened is like they got an initial offer for like X amount, and the city was like, no! And then they were just looking at like how much of the city was down, and they were like, oh, no, now it's this much. Oh, libraries too. Terrible, But another one that there was a fairly famous breach was 23andMe.
Oh,
Yeah.
Crazy.
Yeah, so if you're not familiar, 23andMe is, I don't even know why people do this sort of thing. It's very interesting, the human psychology, but the 23andMe website is basically you spit in a jar and you send it to a lab and they sequence your DNA and they give you a little bit of information about like genetic markers and whether you might have X disease or Y disease, which a hospital would do for you confidentially. But you can do it on the internet, and in exchange for this, information which you're trusting this private company to be truthful about, in exchange for that, you give them your DNA. So yeah, for some reason, a whole bunch of human beings thought it was a good idea to give random strangers their genetic code, and surprise, surprise, they lost it. They were hacked and they lost it, and now you can probably find, if you used it, you can probably find your genome on the dark web. Yeah. Right?
Did they declare bankruptcy recently?
Did they?
I think so.
Good.
Yeah, but then someone can buy them out.
Yeah. Well, I suppose. Yeah. The question is, what happens to all?
What if like Microsoft buys?
Oh goodness.
Realistically, it's probably gonna get bought by a 3-letter government agency, and now they have access to all that
Yeah.
DNA
Yeah.
stuff
Not good enough to
In,
just have the fingerprints, eh?
in a legal way, as opposed to having to go through all the regulations for like how you have to go through the
Yeah.
doctors,
Yeah. Like.
because that doesn't have the same confidentiality.
Yeah. Like if you want your genome tested, it is possible to not have to use a commercial entity to do so. Now, it won't tell you if you're like descended from Belgians that were fleeing the war or something, but like humans are strange animals. Like public relations, right, is a strange kind of a business. Like, I think the guy who invented it was like the nephew of Sigmund Freud. I'm pretty sure. And like, it's interesting because there was kind of this turn with human beings where like companies had difficulty getting people to fill out marketing surveys. Then they started making the questions on the surveys about the people. It's not like, oh, how many times do you use soap brand soap? It becomes like, how many, what do you, if you go to a party, are you the life of the party or do you prefer not to be the life of the party? And it's like, people hate saying what kind of soap they use, but they absolutely love talking about themselves because they're vain and prideful. And the companies realized that you can actually take this data that people will happily fill out about themselves, because it basically boils down to doing personality tests, right? You can use that to like profile people for the types of products that they're going to buy. And anybody who's not in a business program knows that's evil. But yes.
Yeah, it's just pure marketing. So
Yeah.
if you're cool in this, you should use this. Everyone will love if you use this. Or something.
Well, this is actually like this is like it's lifestyle marketing, right? It's like you don't advertise the car as a way to get you from point A to point B. You advertise the car as, I'm putting a sexy woman in the car, right? Because I am trying to sell an automobile by using the sex drive, which is a Freudian concept, right? But yeah, it's pretty terrible.
Almost every product has an association with something. So if you
Yeah.
like trucks, even just regular any trucks, like they're associated with country and this and
Yeah.
the,
Well, it's because they're not actually selling the product. What they're selling is an identity, right? It's like, those little signs that have like stupid sayings on them? There's really no reason to buy them, except that you think of it as like a reflection of your own personality, right? Like the t-shirt that says, don't talk to me till I've had my coffee. It's like, think about how bizarre it is that a person would put something on their chest that says that. And yet it happens, right? Like, how is it that you as a person derive your identity from the fact you drink coffee, and you somehow think that makes you an individual, when literally a billion people drink coffee in the morning, you know?
Or the iconic I paused my game to be.
Yeah, it's like, goodness me. But anyway, so yeah, human beings are terrible and the weak link in any security system. Oh, I remember that other thing. You can tell I didn't get much sleep last night because, like, when I don't get much sleep, I just ramble. But so I remembered the thing. So ChatGPT, the stupid chatbot, all right. They did an experiment with it one. This is a somewhat apocryphal story. I can't verify it, but I heard that this was a thing that it did. All right. Somebody took it and did the jailbreaking on it. Probably, you guys have heard of jailbreaking ChatGPT, right?
The prompt.
Yeah. So they did the jailbreaking procedure on ChatGPT, and then they asked it to hack into someone's account. Right? And it did. And do you want to know how? Of course you do. It's a story. So the way that ChatGPT hacked into this person's account is they called, using a telephone, the company that the account belonged to, pretended to be blind, and eventually the customer service representative let the chatbot into the account. Because you wouldn't question a blind person, would you? Right? So yeah, in that case, the weak link in the security was the customer service agent. Right? But yeah, that's, yeah, nasty little thing. So let's talk about the different types of XSS attacks, apropos of nothing. So there are three main categories. You've got stored or persistent XSS attacks, reflected, and document object model based attacks. So the scenario that we ran with Bob and Gertrude and Hunter the Evil Hacker was a reflected XSS attack. The object of the attack was not to damage or change in any way any of the files on the server, right? The attack was contained in the incoming packet, and it was contained in the outgoing packet in such a manner that it would be executed on a client machine. So it's not, it's like a mirror, right? It hits the mirror, it bounces back. You see your own ugly reflection. The reflected XSS attack, right? The server itself is not modified, yet the attack gets through. The stored or persistent attack is much, much worse. In a stored XSS attack, the evil hacker manages to get some malicious code into the server's database or data files. Most of the time, this isn't targeting the PHP itself, right? To actually modify the PHP in this manner, you would have to be doing something phenomenally stupid, right? Like taking the contents of a text box and executing it on the server as a shell script, or something ludicrous, something equally ludicrous, right? So most of the time, it's not the PHP that they are trying to infect. What they're trying to infect is information that must be retrieved from a database and then is still displayed to the user. So, for example, take an internet forum, right? Let's say, just for the sake of it, interest, you're on web forums. A lot of the time you can use HTML tags, right? You can embed content in forum posts and that type of thing, right? Should you be able to do script? No. No. But if you're not looking for it, you can imagine a scenario where somebody wrote a web forum and accidentally gave the users the ability to write scripts into the web forum. If you do that, then, and if somebody embeds a malicious script that way, you have a stored XSS attack. Now, the persistent or stored XSS attack is much worse than the reflected attack. The reflected attack, in the overwhelming majority of cases, requires you, the end user, to do something stupid, right? You click the bad email link. You, go to the sketchy website, that sort of thing. In the case of a stored attack, you, the end user, do not have to have done anything wrong. In fact, it's unlikely that you did anything wrong. You were simply, to pick a random example, trying to figure out how to install NVIDIA drivers on your Linux machine for the umpteenth gazillionth time. And you're looking at a forum post, and as that forum post loads, you've been got. As the attack can even hide behind legitimate looking information, right? So, the only real way to defend against something like that is to use a script blocking add-on. And that's about it. Right? So, then you have something like you have the document object model based attack. So, in this case, the malicious script is embedded directly into the document object model of a web page. The script is not initially present in the server's response, but dynamically added to the page's DOM through JavaScript. The intent being, of course, to fool any first pass is what is good enough filters to try to prevent JavaScript from loading. So, yes. Any questions? Okay. So, hacking is bad, don't get hacked. Do not use your powers for evil. So, files then. So, computer systems have two main forms of memory. What are they?
Short-term memory for RAM and long-term memory in like hard drives or SSDs.
There's a term for it. RAM and ROM. Yes, that's right. What does RAM stand for?
Random access memory.
Random access memory. What does ROM stand for?
Read-only.
Read-only memory. Very good. So, up to now, in your programming journeys, your programs have only had access to which one? The RAM. That's right. You've only had access to random access memory. File I/O is how you gain access to ROM, read-only memory. So, what are some of the differences between RAM and ROM? What are the trade-offs? What characterizes them? Why don't we just have one memory system? Why do we need two?
Ram's temporary.
RAM is temporary, yes. It doesn't survive the power cycle, right? As soon as it loses power, it also loses all of the data in it. This is, in hardware terms, known as volatility. So, RAM is volatile memory. What's another difference between RAM and ROM? Speed is a big one, that's right. In hardware terms, the more volatile the memory is, the faster it can be accessed. There are actually forms of memory that are used in places like the CPU and other places, which are so volatile that any data you put inside of them will be corrupted in a matter of seconds. Right? These are things like SRAM and DRAM cells. So you may ask yourself, what is the purpose of memory that is rewritten, or that's completely unusable after a couple of seconds? It all has to do with the refresh rate, right? Memory inside of the CPU is going to be refreshed, a couple of billion times every second. So the fact that it completely corrupts after, 2 seconds, well, that's like 5 billion write cycles. It doesn't matter, right? For the space of time where the memory is relevant, it stays uncorrupted, right? That's the fastest form, and that's used for things like CPU register memory. RAM, your RAM chips, they are accessed more slowly. They're more permanent. They're as permanent as your session, really. And it's gotten better over time as well. But if you're wondering why the typical IT solution, have you tried turning it off and on again? The reason that it works is because when errors occur, much of the time those errors occur in RAM. Perhaps the RAM has been slightly corrupted, some bad values have come into existence, something like that. Perhaps you have memory leaking all over the place because your operating system is Windows. And if you completely shut the computer off and reboot it, all of your problems go away. But this doesn't happen with hibernate cycles. Does anybody know how a hibernate cycle works?
Does it get rid of the RAM memory and keep the ROM memory?
Say a little louder, please.
Does it get rid of the RAM memory during hibernation?
It doesn't get rid of the RAM memory.
It's like hashing on storage or something, but then once it loads it back into memory, once it's out of hibernation?
That's precisely what it does, yes.
Oh, yeah.
So during a hibernation cycle, because with your computer in hibernate mode, it can actually be in a powered off state, right? What it does is it takes the state of the RAM, writes it to the hard disk, and then on boot, it leaves itself a few flags to know, oh, I'm doing a boot from this memory which has been stored, so it restores the state of the RAM from the hard disk. That's how a hibernate cycle works. Does that clear errors? No, you have to actually do a hard reset. I don't know if they do this anymore, but it used to be the Windows operating systems only pretended to turn off when you told them to turn off, and like there was a setting that you had to go in. Like it was actually just a deep hibernation, and there was a setting that you had to go into user account. I think this was Windows 8. You had to go into the user account and tell it, no, when I tell you to turn off, you have to actually turn off. That was actually the last Windows operating system that I used. So, yeah, Windows 8 is terrible. But then again, not so very I actually didn't mind the interface. Most of the people most people hate Windows 8 because of the Metro tiled interface, but I didn't mind that so much as the fact that it was Windows.
Windows 10 is good, Windows 11 is awful, I hate it.
Yeah, even though you think that Windows 10 is good, it's still only good relative to other Windows operating systems.
I mean, everything works on it for me, and that's my main way of judging it.
Yeah.
Whereas Windows 11, everything doesn't work.
Well, it's, there's this interesting thing which Windows has always done, which is they always design the new operating system for new hardware, so it's always a trap to upgrade the operating system version on a Windows machine. That's always a trap. Because all they're doing is putting an OS on there with higher system requirements so that when you upgrade your system, it suddenly runs a lot worse in a lot of subtle ways. And it's normally the impetus people have to buy a new computer is that their computer is slow, right? Which is interesting, that's true though. That's the way that most consumers think about computers because they're not educated. Perish the thought that they might defragment their hard drive, right? You guys know what disk defragmentation is? Put your hands up if you know what disk defragmentation is. I'm disappointed in the rest of you. Alright, so this is what disk defragmentation is since we're talking about file systems. So, to know what defragmentation is, you first have to know what fragmentation is. Alright? So, let's say, just for the sake of argument, where's my eraser? Here it is. Let's say, just for the sake of argument, you have a hard disk, alright? Hard disk represented as a grid. Let's say that you have disk usage that looks a bit like this, alright? Now let's say that you're trying to write a reasonably large file into your hard disk. And this reasonably large file, you guys work with reasonably large files. Video files are often in the gigabyte range, right? So, you often can't find 4 consecutive gigabytes of free memory, right? So what does it do? It takes as much as it can get, right? And then it puts a little thing at the end saying, go to here, right? And then it puts the rest, right? So this is an example of a disk or a file which has been fragmented once. Right? Defragmentation. Yeah, what? Sorry?
Can you label that? Sorry.
Oh, sorry. So this is new file, 2 fragments. Right? So you can imagine you kind of get this cascade effect. Right? The more fragments there are of files, the more gap spaces there are that are smaller to put more file fragments in. So as file fragmentation continues, files become increasingly fragmented because you have to fragment them more and more to fit them in the disk. Right? So at a certain point, things start slowing down considerably. Because the way that the disk works is that, and this is particularly true of physical disks, spinner disks, that sort of thing. But it's true of solid state drives as well. The way that this disk system works is it will read in a block from ROM gets read in blocks, right? So it will read, X number of blocks. It's fastest to read consecutive blocks, especially if you're on a physical disk. Because if you're on a physical disk and you've got a physical read arm, right, with a little magnetic head, if your blocks are stored here and 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 here, you've got to physically move the arm to the positions on the disks to get to them, to read them, and that's physical, that takes time. They're fast, especially relative to like the 1980s or something, but it's still slow because it's physical, right? So basically, reading from ROM takes time, and the more fragmented the disk is, the more time it takes to read anything. So what does it taking a lot of time mean in terms of like end user experience?
Wait time. Time.
Well, it means like load times actually, because once it's in the RAM, it's fine. Load times are loading from the disk times, right? So, if you're like, oh man, it's taking like literally 5 minutes to load Civilization 3, The reason is because all the games files are fragmented and all over the place, right? So defragmentation is you can think of it as a routine cleaning procedure that you do to your disk every once in a while if you are a good custodian of your equipment. What defragmentation does is basically it just takes all of the file fragments, copies them to adjacent parts and removes the fragmentations, and then copies whole files back. So it removes the fragmentations from files. All of your files end up in adjacent memory cells. It reads much, much faster. So load times decrease substantially. Does that make sense? Yeah. There was this one person I have an anecdote from when I was young. When I was a budding lad, in a situation not dissimilar to your own, in university, I had a friend who had a computer, and she said, "Man, this computer is so slow, I need a new computer." And I said, "If you will allow me to speak nicely, softly, and sweetly to your computer for just a moment, I might be able to improve its performance." So I took it, and I defragmented the drive, and then I also used, there was a utility at the time, I think it's still around, called CCleaner, where C stands for crap. Basically what it does is it goes through the operating system and deletes all the temporary files, which tend to accumulate over time, including in web browsers. At the time, and this was 15 years ago, I cleaned 6 gigabytes of temporary files out of this computer, which is a lot. And, because like the other thing about it was the computer really wasn't that old. It was like only a year old, and it had gotten to this state. So I fixed it using this stuff, and she was eternally grateful for like a week. Yes.
Just the other week ago, I was helping my friend, because certain programs couldn't work for the longest time, and I asked him, "Did you ever clean out your computer, your laptop?" He said, "Nope, he had this laptop for 4 years and he never did a full reset or anything." So I was like, you know
never
what?
a full reset.
Yeah, just to clean out everything,
Yeah.
because in my opinion, I usually do it almost every 6 months, just a full
Oh
reset.
yeah, yeah.
And but
It's
he
not-
has never done it, and the fact that, and when I did it for him, I fixed a lot. In the beginning, I realized, oh, I accidentally installed it in the hard drive and not in the SSD.
Ah.
It was running slow. I was like, oh, thank
Yeah.
God. Thank God I recognized that. I fixed it. Everything works.
Yeah. You had a comment, Beck?
I just byboard the story. Whenever my computer starts running slow.
Yeah. So
2 terabyte M.2 right now.
this is less of a problem, surprise, surprise, in Linux operating systems. Because Linux uses a different file system that's less vulnerable to, it doesn't just, you know, you don't throw a file to it and it just breaks it into a million pieces, you know. I was, yes,
So, I can see why this would be more of a problem on disk drives. Is that still kind of the same case for like, let's say, NVMe or SSD?
yeah, it doesn't really matter what the physical medium is, right? Like SSDs are faster because you don't have to move a physical read head. So it is faster in general, but the way that the hard drive works has not changed. Like you're still paginating blocks into RAM from ROM. So the question then becomes, you know, if you're reading a random block into RAM, how much of it has the data that you're looking for, right? Are you wasting 10% of your space on that block? Are you wasting 50% of your space? Are you wasting 90% of your space, right? So yeah, SSDs, you still do have to defragment them because it's fundamentally a software problem, not a hardware problem. So, there are only 2 types of files. This may go against common or received wisdom, but I tell you, there are only 2 types of files. And I can hear the complaints now, but professor, there's .doc, there's .png, there's .jpeg, there's .jpeg with an E, there's .xls, there's .php. These are all different types of files. No! There are only 2 types of files. What are they? See? Nope. That's actually a permission that you set on files. You can technically make any file executable. Yes?
Probably not the right answer, but it's on the thing there, so.
Oh, that is actually the right answer. Sometimes I just test
Yeah.
people to see if they're reading the slides.
I just did, I wasn't entirely sure, but I'm gonna be like, I'm pretty confident.
Yeah.
Maybe he is, but I don't want to look stupid.
There are text encoded files and binary encoded files. Can anybody give me an example of a binary encoded file?
An image?
Image files, yes. Yes.
I was gonna say image, so.
Well, what's a type of thing where you take a bunch of images and you run them together?
Video.
Video file.
GIF file?
Which what?
A GIF?
GIF, yes, animated GIFs. Sorry?
Yeah.
A doc file, well, that's interesting actually. So the docx format is binary encoded, but all it is just kind of a slight binary encoding that's masking the fact that under the hood it's actually just an XML file. Word, Microsoft Office products just run on XML files, by the way, that's why they suck. Yes? Louder?
Audio file?
Audio file, excellent example. Audio files, MP3s, dot waves, all of those are binary information. Yes?
TXT?
TXT is text encoded. Yeah? Yes?
Is there a reason Microsoft file extension, is there a reason they have X's at the end? DocX, XLS, X, PPTX, what's up with the X?
So,
Probably the name.
I'm so glad you asked. What's up with the X on docx, right?
Yeah.
So, I think they chose the letter X because it's cool,
Elon Musk
right?
stuff.
Or it stands for extended.
What are they extended?
So, my understanding of the primary difference between like the .doc and the .docx is the binary encoding. So, it used to be, if you took like Word from the early thousands or the 90s or something, right? The Word file itself is just an XML file, right? Let's see if we can. Maybe we'll be able to do this. Yeah. It's on the plane a little bit. So, if we save this, I saved a copy of this as, it'll probably dump it in documents somewhere. Nope, haha, automatically redirects to the cloud. Stupid thing.
Or his auto save.
File, save a copy to this PC. See, this is another one of the reasons I hate Microsoft, you know? It's like, I should have my file. Okay. So, documents, save it,
I mean, all you need to do to fix Windows is just obliterate Windows.
like I'm low-key really kind of looking forward to when the Chinese EMPS into oblivion, just saying.
It's gonna be the sun that does
Yeah. So then if I try the 97-2003 format, save. Let's take a look, shall we? So, one thing that you may notice immediately is the file size. The old file format takes up more than double the space. And what's likely, and the reason for this is probably because of the binary encoding. Binary encoding often acts as a compression, right? So, let's take a look at our .x format first. Open with Notepad. So Notepad, you can use Notepad to interpret any file. If it's a binary encoded file, it ends up looking a bit like this, with oodles and oodles of random characters, because each of these characters represents, essentially it's hexadecimal data, right? So it's not, when you try to interpret it as text characters, it's meaningless, right?
It says .xml at the top as well.
Well, I mean, a few pieces aren't, right? Content types .xml, for example. You know, you'll find a few pieces strewn throughout Word/font table XML, for example. But if you were to try to search the word Spain, it's not there, it's been binary encoded, right? But like, you can tell from the fact that these are probably import statements that it's still XML. It just doesn't look like XML because it's been garbled. So, and I'm going out on a limb on this just slightly. We'll see what this looks like.
It's interesting when you try to open files that like aren't designed for it. That's like an archive.
Yeah, it's fun, right? So we do have a bunch of binary information, right? But then, just keep scrolling down. There's my name, as author. Oh, the word Microsoft Office appears. Keep going. Uh-oh. Things are looking very XML. right? And if we're lucky, yeah. I guess they are actually putting the content into that front bit, but that's a shame. But anyway, basically, the old Word document, I guess, format spent too much time saying nillable true. So, yeah. And increasing in the binary, that's the main difference between the two. So, text encoded files. Normally, you're dealing with ASCII, sometimes normally UTF-8. Technically speaking, ASCII only defines 7 bits. Extended ASCII defines 8 bits, and UTF-8 is the same as extended ASCII. UTF-16 is all of the characters. Most programming languages do not support UTF-16. In fact, most programming languages won't go beyond original ASCII code. You guys know what UTF-16 is? Am I just speaking words meaninglessly?
Heard this
No,
before, I think. You know the one you said.
Yeah. Or I could just tell you.
Yeah.
So,
Oh, okay. Yeah, I know what it is.
ASCII, right? Text encoding is based on the number of bits that you're using. Each bit value corresponds to a character, right? Does that tell you how many UTF characters, UTF-16 characters are currently defined? You could Google it.
I think 1.1 million.
That seems large.
Yeah, 1,112,064.
Really?
To be precise.
That's the number of UTF-16 right now.
Yeah.
That's like an order of magnitude more than I thought it was. Somebody's been busy. Yeah, so there are 1 million UTF-16 numbers, but the number of 16-bit numbers is still greater than that by quite a margin. 2 to the power of 16. Wait. What?
That's right.
Yeah. Then how can there be 1 million?
Somebody's been busy.
Yeah. You'd need like
Maybe include also-
TF-32. I think you're okay. Number of defined Unicode characters.
Apparently,
Okay, well that.
Currently 150,000. Okay. I think you might be wrong.
I think Google's wrong here.
Yeah. Because that number still doesn't fit inside that other number. Well, at any rate, text files are text. Moving on. Yes?
apparently there's a theoretical 1 million, but when you have more than that 65,000 number, they're encoded as UTF-16 pairs.
Of course they're encoded as UTF-16 pairs. What that you know what that is? You know what that is? That's a fancy way of not saying UTF-32. Yeah. Yeah, okay. Well, at any rate. So the text files contain text. Fundamentally, this is not different from the string data type that you've been working with in computing so far. So, the object of file I/O is to convert between files on the disk and strings in your program. Make sense? When we do this, But when we actually eventually get to doing this, come you, come on, there we go. The operations which I'm going to show you are not the most efficient way to do things in PHP, but I am going to show you the most transferable way of doing file I/O, so that I'm not just teaching you how to do it in PHP, I am teaching you how to do it in C, C#, C++, Java, PHP, everything you might want. Alright? Because fundamentally, no matter how much, did I say Python? Python 2. No matter how much window dressing you give it, all file I/O functions ultimately refer back to the C standard library functions in the kernel, contained in a file reverently termed stdio.h. stdio.h, nothing to do with STDs, get your minds out of the gutter. Standard input and output.h. It also contains the definition for printf, which is the function, printf, print function. That's the function that every other print function is actually using to print things. So when you say print in Python, it is a Pythonized thing that ultimately invokes printf. Incidentally, in both Java and in PHP, you have access to printf directly if you want it. We will not talk about formatting strings. If you want to know about format strings, go look them up. So, text data with opening files, we must use a function called fopen. File open. This opens a file. At least it attempts to open a file. Can anybody tell me one or two reasons, one reason each please, why opening a file might fail? Yes?
Doesn't exist.
The file doesn't exist. That's a good one. Included in the category of file doesn't exist is I misspelled the name of the file I'm trying to open. Right? The computer can't correct your spelling. It doesn't know what you mean by that. Right? You write your file name precisely to the character, or the computer can't find it. By the way, that is the same standard which I am applying to your assignment submissions for CS Unix submission. If you don't use the file name on CS Unix exactly, with exactly the right folders, with exactly the right sequence of capitalization,
0.
well,
-1.
I mean, as much as I'd like to, no. What the course's actual policy is that I send you an email telling you to fix it, and then you have 1 week to fix it. After that, it's a 0. So, if you get an email from me telling you to fix your damn file name, I recommend doing so, because, only 4 assignments in this class that are reasonably weighty, right? It's silly to lose 10% of your grade because you were too proud to change your file name. Alright? So, also, in the category of skills which you shouldn't be in 3rd semester if you can't handle, naming files is on that list. Right? So, what's another reason a file may fail to open? Yes?
I think you mean the metadata, something wrong with it.
Something's wrong with it, like it's corrupted or something? Well, so that's something a program decides about the file once it's been opened, right? The actual opening procedure would not make such considerations because that consideration is not made at the operating system level. Yes?
Maybe choosing the wrong extension.
Choosing the wrong extension? Well, again, so any program can open any file of any type, right? There's no physical restriction. File extensions are kind of fake, right? So file extensions are a part of the file name. If you've got the wrong file extension, you therefore have the wrong file name, right? Like, if I try to open data.txt, but the file on the thing is data.data, right? It's not going to find it because there's no file named data.txt. So it's a file not found error, not a wrong file extension error. Does that make sense?
It does.
Insufficient permissions.
Insufficient permissions. That's a good one, and particularly Unix/Linuxy. So you are programming in a Linux environment, so what I say is relevant. The Unix file permission system is reasonably complicated. There are three levels of permission in the Unix file system. You've got root permissions, you've got group permissions, and you've got user permissions, right? So depending on who the owner and the group owner of the file is, right? Am I allowing every user to see this file, or is it just for me? Am I allowing every group to see this file, or is it just for me? By the way, a good example of groups, you know on CS Unix how all of you have student accounts, but I have an instructor account? Though we're in different groups. You guys are in the student group, I'm in the instructor group. If you want into the instructor group, you're going to have to be here for a bit longer than this. Oh. So, if you do not have permission to access the file in the manner specified, you will get a file error, right? We can read files we can open files in read and write modes. So if you're going to put it in like Windows terms, if you're trying to write to a read-only file, you can't, right? You have to change the permissions first, at least. Okay, so we've got file doesn't exist, you don't have permission to access it. I'll give you another one, all right? File is already opened by somebody else, right? So, this is more a thing for writing, not reading, because reading is a non-destructive process. You can read something as many times as you like, it doesn't alter what you're reading. But writing is a destructive process. So, what will typically and often happen is a file cannot be opened for reading, can't be opened for writing while someone else is writing to it, right? This is a way of managing file permissions. Because fundamentally, has anybody heard of a race condition? As in, yeah, like that kind of race, you know? So in a race condition, the person who comes last wins when it comes to files and file write operations, rather than the first person winning. So, this is how it works. So let's imagine a scenario. Let's say we have person A, person B, and let's say we have file C. Both person A and person B have to do something with file C. It doesn't really matter what, right? Let's say that both obtain a copy of file C at around the same time. Alright? Although, honestly, so long as one person gets it before the other person puts their changes in, this is still the working scenario. So let's say that person A is a good and diligent worker, gets immediately to their assigned task, does not procrastinate at all, and we have C with A's changes produced. A then writes their changes back. Let's imagine this is like the shared drive type thing. Make sense? So, person A has their changes written. Now let's say that person B is slightly more, let's give them personalities. Let's say that person A is lawful good. Yeah. Person A is Alfred the nerd. And person B is Slacker Sally. There we go. And how about Slacker Sally is just kind of like and has kind of a very standard haircut. There you go. Slacker Sally also got 3 hours of sleep last night. So, our keener, whose name is A plus Alfred, gets his work in on time. Slacker Sally decides that before she gets to work, she has to be on Facebook for about 53 minutes. Because that's part of her work process. Then afterwards, she produces, and she's also still B. This is still A. There we go. She produces her work. What happens when Slacker Sally adds her late addition to the shared drive?
All the changes from file A will get with the win.
Precisely. Slacker Sally adds her file. This overwrites A plus Alfred's work as Alfred's work overwrote the original.
Because she won the race.
Because she won the race by losing. Yes, exactly. So this is a terrible way to organize your company or what have you, to have your latest and most slackiest employees always have final say about what the states of files are. So there you are. This is called a race condition because they're both racing to make the same write to the same place. So, the way that you prevent this if A plus Alfred during the open operation puts a little force field around the file and locks it, right? Then, when Slacker Sally attempts to open the file, she can't. She must wait until Alfred is finished his work, places it back, and then releases the lock. These are also called mutex semaphores. Mutex standing for mutual exclusion. And semaphores, the semaphore is actually, you know the naval language where you hold flags at various angles and that's like letters? That's called semaphore. So at that point, Slacker Sally can get her copy. Her copy must therefore contain A+ Alfred's work. And at that point, the final product has everybody's work. Right? So that's one way to manage your file permissions. The other way is to use something like a repository, which rather than putting the barrier here, it allows everybody initial access, but then whoever commits a branch and tries to merge it is responsible for making sure they're not junking up main with a bunch of merge conflicts. Make sense? Any questions? As I understand it, you guys are doing a little bit about repos in testing? Yeah? Are they doing continuous integration testing with you?
As of right now, no, but we might later.
Hopefully. I don't know, you have to know a little bit of scripting to be able to do it. I'm kind of an advocate for the position that, like, it's kind of interesting, the divide, like, shell scripting is considered a networking thing, but like, there's absolutely no reason why software people shouldn't benefit tremendously from it. Well, okay. Let me ask you a question. All right? Let's say you are making an ice cream plant.
Sure.
Right? You are designing a plant to make like little ice cream sandwiches. Right? You have a machine that makes the cookie part. You have a machine which makes the ice cream. And you have a machine which assembles the cookies and the ice cream. Right? As a software person who doesn't know bash scripting, you can work on the machine that makes the cookies, you can work on the machine that makes the ice cream, and you can work on the machine that puts the two together. What you can't do is feed cookies from the cookie machine into the thing that makes the sandwiches, and from the ice cream thing into the thing that makes the sandwiches, and you can't get the cookies to the customer.
Okay.
Right? You write programs, but do you know how to use programs?
No.
You should, because you write programs for a living. You should not just know how to write the programs, you should also be able to use the programs.
Isn't that what server-side code?
I mean, no.
Oh,
Server-side is for learning PHP.
oh,
I know. As I said, when I'm tired, I get off topic. So, oh man. So in addition to fopen, there's another very important one called fclose. So, oh man. So in our previous example, the function which performed the lock was fopen. The function which unlocked it again is fclose. This is a little bit like freeing your memory, freeing your pointers, which is an old C thing. Now, it is true in PHP that any file handles that are left dangling, when the interpreter quits, they will be released back to the operating system as normal. It's, in theory, you might say to yourself, well, if the PHP is closing the file anyway, why do I have to close the file? And the answer is, because you might not need the file for the entire duration of the script, and it's a server, so it might be running many people's scripts simultaneously. So basically, the thing you want to do with files is you want to open it, get in, get what you want, get out, close the file, and then take the data that you obtained and do something with it. Right? If you keep the section of the code where you've actually got the file open as small as possible, that minimizes the amount of time that that server has the resource locked, which means that you can do things like support more simultaneous users, right? Which is like an actual performance indicator for a website, right? Make sense? So it's a performance thing. Good. We will. Unfortunately, I'm out of time. I can't give you the demo today, but we'll do that tomorrow. Don't worry, we'll do demos tomorrow until you're sick of them. I will show you a function called fgetS, or file get string. This reads one line at a time out of a file. The return result is a string representing one line out of the file. So if I have a file, A, B, C, D, E, F, G, H, I, that's my file. The first call of fgetS returns ABC. C# uses the terminology file stream. And this is why. The return result of fopen is a thing called a file handle. The file handle contains all of the information necessary for reading from the file. One thing in particular, the file pointer. So there is a file pointer which indicates the next line in the file to be read. When you call fgetS, it not only reads that line out of the file, it also advances the file pointer. Now the file pointer is not bound to lines, it is bound to absolute byte position versus the beginning of the file. Because here's another thing that doesn't exist. Lines. Lines in a file don't actually exist. How do files indicate when lines come? Yes?
The new line escape character?
The new line escaped character, yes. So when a new line character occurs, all of your fancy schmancy text editors know to put the next line on the next line. They know to start those characters going on the next line because you hit a new line character, and then they keep going until they hit another one. So yes. New line, the concept of a line in a file, there's only a character corresponds to that. It's not like it's a JSON that has strings arranged into a list or something, right? It's interesting, exploring what is primary in terms of file organization, what is secondary. The fact that the file has lines is secondary because it's dependent on the context. The file format, the general file format for general files does not contain a concept for lines, right? It's just a block of bytes on the disk. That's what a file is. So fgetS advances the file pointer at the same time it's reading lines out of the file. and the end result is you read each line out of the file sequentially. Make sense? Another one that we're going to talk about next time in class. FEOF. Anybody want to take a guess what this one stands for? What this means? File, end of file. So, file operation, test for end of file character. So the way that files know when they end is very similar to the way that a string knows when it ends, using null termination. In the case of a file, there is a special reserved character, the end of file character, which tells you when you've reached the end of a file. Right? Again, the analogy to strings and the null terminating character. So FEOF is a Boolean test. If the file stream has reached the end of the file and nothing more can be read from it, FEOF returns a true result, which we will use to establish a loop which reads all lines out of the file sequentially. Any questions? Questions about files? Questions about the course? Philosophical questions? Yes?
So to complete the assignment, we will be using like all the chapters up until now?
No, actually to complete assignment 1 you only need till last week. Yeah. Assignment 2 is going to revolve around reading and writing files, also converting to and from JSON formats. Aside from that, it shouldn't be, like, there's not going to be that much new material in assignment 2, now that I'm thinking about it. No, it's just file I/O. Just file I/O. Yes?
For the midterm, what's it containing of code? Just, module wise. Because I did email you, but I was the one who was confused about the sections, and yeah, that was me.
I'd have to look. Let's take a look. That's a good question. Coverage
Oh,
for
and
midterm.
is there also a review?
Oh yeah, we'll do a review the previous week. Yeah.
Week before, maybe?
Well, yeah, because for our section we're having the test on the Monday,
Oh, okay.
and the test is the week after reading week.
The week after the week after.
Yeah, it's 2 weeks after reading week.
Oh, it's 2 weeks after, okay.
Yes.
So the reading week review and then test for midterm?
Okay. So I want everybody with your computer to click the little calendar in the corner, so we have a calendar in front of us. All right. Go to October. All right. This week is week 5. The week starting the 6th is week 6. That's A2 being deployed. The week after that is reading week. So the week of the 13th. The week of the 20th is week 7. That's when assignment 2 is due. The week after that, the week of the 27th, this is the week we are having the test in. Okay? And to answer your question about coverage, looks like we will be able to, working files for sure. Oh yeah, we'll be able to do sessions. Yep. So we will be doing, major topics for the midterm. Aside from basically everything up to file I/O, I wouldn't consider major topics in the course. No matter what you're doing, you're going to have to read input, right? You're going to have to know what echo does, all of that stuff. File I/O is major testable topic number 1. Sessions and cookies, major testable topic number 2. Sessions and cookies and file I/O will be on the midterm. Sound good? Wonderful. Any further questions?
No, Your Honor.
somewhat related.
okay?
Um,
People are getting antsy, so
I was wondering, you know what, but, yeah.
I prefer your worship, by the way.
No, I was wondering, could you have two separate drives and install Linux on one and Windows on the other, or no?
Yes, absolutely.
It's
Well,
not
no.
virtual machine.
No,
I meant
like, if you have a desktop and you have an existing Windows machine, you go buy a hard drive, plug it in. You can have a dual boot Linux system.
I mean, you can also just do like WSL or something.
Que me duele, señor.
No, it's actually good. It's actually good.
Not as good as Linux.
Well, I mean, it basically is secondary Linux. If we're gonna make an analogy, it's like primary and secondary in the forms, like the Windows like secondary by support. Still isn't Linux.
See, you have to say this is basically Linux. It's not Linux. So, yeah, actually, so, basically, okay, so this is how it actually works. Your system has BIOS or UEFI, right? But it has a bootloader system, right? If during your boot cycle you hold like F10 or F2 or some combination, you get BIOS.
Although I can see
You have the BIOS. So in the BIOS menu, you can configure one of the partitions somewhere on your system to be another partition. So when you install, you're actually describing the exact process. Oh, right. Basically, my work picture. There's a big sticker on the top of my work computer that says personal property.
Exactly like I'll
Yeah. So when you
Windows 11 is
So when you install Linux, let's say you put a brand new drive in and you install Linux on it, right? You can reconfigure the BIOS to select the Linux boot partition as being the partition that you boot from. This will actually load this will load Grub. Grub is the Linux bootloader. That will actually allow you to select from all installed operating systems. So you could have like multiple Linux operating systems installed on this drive, you just partition the drive, right? So if you, oh, I need my camera.
Or you go talk on